Let's take a look at standard solutions. All right, so standard solution describes a solution of a known concentration. So we want to make solutions that we know a concentration for. How would you prepare 2.0 liters of 2 molar NaOH standard solution? So you might get your NaOH in a different concentration. You might come in a bottle where it's 6 mole. So you have to take that 6 mole solution, and you have to figure out how to deconcentrate it a little bit. Okay, so to dilute a solution means to add more solvent without the addition of more solute. So we make the concentration weaker. Okay, so as an example, we got 53.4 milliliters of 1.5 mole solution NaCl on hand, but we need to make 0.800 molar solution. How many milliliters of that can we make? So we've got a more concentrated solution. So we're going to add water here. We're going to add water to this until it becomes this. Okay, so what do we know? Let's take a look. Well, in this we know a volume and a concentration. That means we can find out how many moles of NaCl we have. And then once we know how many moles of NaCl are in here, then we can figure out how much liquid we need to make that concentration. Then we can determine how much to add. So we're going to start with, so what we know is we know the concentration. We're going to figure out the moles. Then we're going to figure out a new concentration. We need to figure out the volume of that new concentration. So that's kind of what we're doing. So our first concentration is 1.50 m. 3 significant figures. So now we need to figure out how many moles there are based on this. So we write out our formula. Concentration is equal to moles per liter. 1.50 is equal to how many moles in 53.4 milliliters. Oh, we don't want milliliters. We need liters here. 0.0543 liters. Your conversions from milliliters to liters should be instantaneous in your head. No doubts about it. So we're going to take this and multiply by 1.5. 1.5 times 0.0543 is equal to 0.08145 moles of NaCl. This has 3 significant figures because we had 3 here, 3 here. Now we know how many moles of NaCl we have. We want to make this concentration. So what volume do we need in order to make that concentration? So in our second step, we want a volume. So we know our moles is equal to, our molarity is equal to moles per liter. We want our molarity to be 0.800. And we have 0.08145 moles. How many liters is that going to be? Well, when we got this form, we do this. Liters is equal to 0.08145 over 0.800, right? We switch these two guys up. Then we divide that out. It's equal to 0.1018125, or 101.8125 milliliters. So we want to get this to 101.8125 milliliters. If we can get this to 101.8125 milliliters, it will have this concentration that we want. So we have to figure out how much more we need. Well, this is how much of it. This is answering the question here. How many milliliters of 0.800 molar solution can you make? We can make this amount. 101.8125 milliliters. Now, if the question is asking, how much more solvent do we have to add to that in order to get this? Sorry, with proper sig figs, it would be 102 milliliters. How much more solvent do we have to add to this to get to that? We could take our 101.8125, because that's how much volume we want it to have in order for it to have this concentration. But we have this amount, so we have to add water in it until we get to this amount. So we would subtract our 53.4 milliliters. So we would need to add 48.4 milliliters of water. Okay, so we can make 102 milliliters of 0.8 molar solution. And to do that, we'd have to have add 48.4 milliliters of water to that. All right, so we dilute it. Right, we take our concentrated solution, we add more water to get a less concentrated solution. To get this exact concentration, we would have to add that much more water to this in order to get this exact concentration. Okay, so the second one is very similar. 100.0 milliliters of 0.2500 moles KBr solution is on hand. If we need 0.55 moles, what is the final volume? So we're going to add it till we get to a final volume. So we have our concentration. We're going to go to moles. We're going to take that moles and we're going to go to a concentration volume. So our concentration is 2.500, 4 sig figs, 4 sig figs, 4 sig figs. So we want everything to be in 4 significant figures here. So our concentration is that. So we write out our formula. Molarity is equal to moles per liter. So we got 2.500 is equal to how many moles in, that's got to be in liters, 0.1000 liters. So we take 2.5 and we times it by 0.1. 0.25. So our moles is 0.2500 moles. So this is how many moles we have, and we know the concentration we want. We have to figure out the volume, the final volume for this. So we do our formula again. Moles is equal to moles per liter. Right now we want this concentration, 0.5500 is equal to 0.2500 moles in how many liters? This gets flipped around to get 0.2500 divided by 0.5500. We get our liters is equal to 0.4545. So our final volume will be 0.4545 liters. So we started at 100 milliliters of 2.5 molar KBr solution, potassium bromide. And we want this concentration of potassium bromide, so we have to add water until it gets to this volume. And then our concentration will have gone down from 2.500 m to 0.5500. Now, in these ones, we're adding water. You add water, you dilute it, you lower the concentration. It is possible to let water evaporate and increase the concentration. the math is all the same. The math and the way you set it up is all the same. All right, so calculate the new concentration molarity if enough water is added to 100 milliliters of 0.25 m sodium chloride to make up 1.5 liters. So this time, we have a concentration. We're going to go 2 moles. And then we're going to go to just a new concentration. So first concentration is 0.25 at 0.1 liters. Now, according to our final thing, this is 1 sig fig, this is 2 sig figs, this is 2 sig figs. Our final answer is going to be 1 sig fig. Our final concentration answer is only going to have 1 sig fig. So to go from here to moles, we use our formula. Molarity is equal to moles per liter. 0.25 is equal to our moles in 0.1. So we do 0.25 times 0.1 to get 0.025. Oh, I better check that. 0.25 times 0.1, 0.025. 0.025 moles. Now we're trying to figure out a new concentration, and that's pretty easy to do. We just do m is equal to moles per liter. There's our liters. 0.25 divided by 1.5. Now this guy should have 1 sig fig in it. This guy should have 1 sig fig in it. So our final answer will have 1 sig fig in it. So we do 0.025 divided by 1.5 is equal to 0.01666. So it's capital M. That's rounded to the correct number of sig figs already. That's our molarity. So we started off with this concentration, and then we added enough water. We added like 1.4 liters of water to it, and now it's this concentration. All right, so the main thing with all of this is planning out your steps. What are you doing? How are the steps going? What do you know? What can you go to? And then can you go from there to something else? All right, so I hope you understand what concentration is and how we measure it in moles per liter. And our formula, molarity is equal to, moles per liter is important. Diluting a solvent is adding liquid in and making the concentration go down. You can let water evaporate, and that concentrates the solution. So it increases the concentration. All right, so thank you for watching.